Put that down. Down. Cool, cool. It's a little high.
On a Sunday.
On a Sunday.
There we go.
That's the surprise.
All right. Check, check. Mic check. Is that good? Sound good? All right. Hello, everyone. Welcome. Turn that up just a little bit. Cool. Thanks all for coming out. Man, what a crowd. You guys, awesome. This is probably our sixth DEVx meetup, I want to say. So thanks again for coming. For those of you who don't know, this is San Diego JavaScript, obviously. You probably know that. Organized by 4 of us. AJ over here, DJing right now. Myself, Sam, hi. And Tristan. Where are you, Tristan? There he is, Tristan. And Zane in the back. So we're just a community of local developers. A little bit about us. Yeah, like-minded developers. We just get together here in San Diego to share some ideas, bring together a real community, and our goal is just to meet, learn, and regardless of skill level. So we get all kinds, like professionals or newcomers that are just learning, people that are just interested. So we all just come together and start coding and doing some fun stuff. So that's the most important part of what we do, is having a lot of fun. So big shout out to Edge hosting us tonight. This is Edge HQ. Edge is a crypto wallet app that is really focused on self-custody. For those of you, who here knows about crypto, first of all? Okay, cool, we have a good handful. So self-custody, meaning you get to own your own keys. That means that it's not necessarily Coinbase holding your own keys, so you get really the sovereignty there. And also the privacy as well, so people don't know what you're doing with your finances. So we're big on those 2 things, but you can do all the cool stuff like buy, sell, trade, all of that from within the app over here if you see the little flyer. So another thing so thanks to Edge for hosting us. They're an awesome company. Full disclaimer, I'm one of the software engineers here at Edge, so if you have any crypto questions, feel free to ask me later. Wi-Fi is right here. If you guys can see, Edge guest is going to be the Wi-Fi, and if the password is going to be I like big bits, all lowercase. So feel free to connect there. And also restrooms. If you guys haven't already been, it's going to be on the outside. Make a left before the elevator and all the way down. There shouldn't be a code, but if there is a code, feel free to ask me. I'll get that sorted and get you the code. So, all right, so a little bit of what we're doing today. We obviously had lunch. Who here liked the pizza, the beer? Cool, awesome. Big thanks to Tristan for ordering the pizza and AJ over here snagging the beer on the way. So yeah, we do a little networking, lunch, and then now we're going to be doing some speaker presentations. We have 3 speakers today. So, and then after that, we'll be breaking away to again network and also follow up with some sessions. If you guys brought your laptops, awesome. We can start coding together and learning. So that's really fun. And then towards the end, around 4-ish, soft stop, we'll start closing up. So our speakers today are going to be first by Jay. We're going to have 3 words that will make your app much better. He's going to be doing a deep dive into performance using proxies, local first sync systems, and a bit of developer experience using Legend State, his state management library, all within JavaScript, I believe is going to be TypeScript, maybe, one of the 2. Next, we'll be doing a talk, a little bit different talk than we usually do, but really awesome nonetheless, on video game development by Brandon Jack. And that's going to be doing a bit of a talk on exploring like the artistic side and the creative side about game development and kind of how that merges in the game industry. So he probably is going to explain it way better than me. So that's going to be an awesome talk to follow up. And then following that, Next.js, really excited for this one because by Colin Casson, hopefully I'm not botching that. He's going to be doing a talk on how to use Next.js to make React a lot better in developing in React. So yeah, enough of that. Without further ado then, let's welcome our first speaker, Jay, up to the stage.
Okay, mic is on, all good?
Yeah, perfect.
Yeah, all right.
Take it away.
Okay, so hi, I'm Jay. This talk is mostly React-based, but Legend State works theoretically for anything. I just haven't built the other plugins for other frameworks on it, but hopefully soon. So I have 3 words for you to make your apps better. But first, I make Legend, which is a local-first productivity app, combines documents, calendars, and a built-in browser. Some people have documents that get up to 100,000 items. You can have multiple documents open at once. So there's a lot of optimization in there. I'm also working on Bravely, which is a platform for therapists to run their practice and collaborate with their clients. And they're very different, but these 2 apps have a lot in common. They should feel as fast as a local app. They should never block users with spinners. They should sync perfectly. So I built a state and sync system to do that for both apps. And I learned a lot about how to make great apps along the way. So Legend State is all about observables. It's conceptually similar to MobX, or you could think of it as signals or runes, but with hierarchy. So you can create an observable from a primitive, an object, an array, whatever you want. And then you can just set any value on any node in the hierarchy whenever you want. And then if you get inside of an observer, then it tells the observer to rerun whenever it changes. So here where I'm getting name, that's telling this component whenever name changes, rerun. There's also some special reactive components, so you can just give it an observable and it'll 2-way bind to it. So that brings me to the that brings me to the 3 words to make your apps better. Render less, less often, which is 3 different words. Let's look at a common problem in React first. So we have state in a component. That's all normal. But if you want to have a sibling component that you want to use the same state, then you have to lift up the state. So then you have state in the app component, and it goes down into both of them. But now you have a performance problem, because whenever you change name, it has to re-render the entire app. And so the way you solve that in React is you wrap components in memo. And so now when you re-render the entire app, it sees that name didn't change, so it doesn't have to bother. But then what if you have an object instead of a primitive? Because now when you set the name, you have to clone the user and put the name into it. So now the object is different, and so all the memo strict equals checks fail, and so you're re-rendering your whole app again every time you change the name. So the way Legend State does this is similar to if you've used Signals or MobX or Svelte or Solid or Knockout.js back in the day. The profile is an observer. It observes the name changing, and so when the name changes, it re-renders. The username just passes it straight into that reactive component, so username never re-renders at all. So in practice, what this looks like is a normal React app on the left. It's just incrementing count. Every time count changes, you see the flashing box. Every single component is re-rendering and all the way down the tree. But in the Legend State way, you have the observables on the right. Only the 2 little count numbers are changing. Nothing else needs to re-render, because that's all that cares about that state changing. So this, along with a lot of other optimizations, is what makes Legend State faster than every other state library, and even vanilla React, because there's some optimizations around arrays where we don't have to re-render the whole array. We just re-render the 2 things that changed. So those 2 where it's green instead of yellow or red, it's just much faster. So that brings me to the 3 words that will make your apps better. Write less code. It might surprise you, but writing less code is better. You're less likely to create bugs. It makes your bundle smaller because there's less code. And doing less work makes your apps faster. And doing less work makes you faster. So I'll show you some examples of that. So normally in React, you have your state and you have callbacks. So when the input changes, you set the state. Legend state just does 2-way binding, so you don't have to deal with any of that. And then normally you would have use effect with a bunch of dependency arrays, but legend state knows the dependencies of everything. So when you use observe and you're getting the name, it tells that observe that you're tracking name, and so whenever name changes, it'll rerun. You don't have to manually tell it what the dependencies are. So you can just stop using use memo and use effect. You don't need them anymore, and that makes your code much less error prone and just less annoying. There's also no immutables. So legend state knows exactly what values you're changing, so you don't need immutability for the comparisons. React normally uses immutability to check whether an object has changed, because if you just change a property of an object, the object itself didn't change, so it has to just clone everything. And so without needing to do immutables, you can just set the name directly instead of cloning a whole object. And this is also much better for performance because cloning creates a bunch of new memory, which then has to be garbage collected, and that's slow. And doing basic sync in React is very complex. First, you have a use effect to get the data from it, and then you have a use effect when the value changes to post it, and then you have to have your local state, like I'm saving, I need to show a spinner. If you want to persist the data, you have a bunch of other stuff to do. So it just gets huge. You just shouldn't try to do sync yourself. So you should probably use a sync library. There's a whole bunch of them. I've personally never used any of them. And I don't think you should have sync code in React at all, which is why observables sync themselves. So in normal React, when you click a button or type in an input or whatever, you send the data to the server. You wait for the server to finish processing it. When it comes back, you save the remote state back in your local state, and now everything works. But that whole time, you had a spinner there. And so here's the way that would work with React Query. This is from their quick start example on their website, which is so big, I had to shrink it. So we can zoom in a little bit to just the mutation. So when you do a mutation, you mutation.mutate with the new data, which then triggers React Query to go and set, call the mutation function, which then waits for the mutation function to succeed, which then triggers an invalidate, which tells it it needs to get again. So then it goes and gets from the server again, waits for that to succeed, and then you're finally finished, and you update the local state. There's some new ways to solve that. React 19 has a hook called useOptimistic. So the way that works is before you send the data to the server, you add an optimistic to do, which is like, I think this will probably work. And then you work with your local copy. You wait for the remote version to come back, and then it replaces the local copy with the server version. I find this really confusing. I know how this works. When I look at that code, I don't understand it, but I do understand it, but I don't understand it. It's just a lot of code. And so the way legend state does it is first you update an observable, and it syncs itself. That's all you had to do. So the way that works is first we set up how the observable syncs itself. So we say we have to-dos, we get it from a URL, set it to a URL. And then when we get the value, that tells it that I care about it, which will trigger the get, and it will go and get itself and update itself when it comes in, and then using that observer pattern before, that will then update itself when it comes in. So then when we want to set, we just set on the observable, just on the local state. And so since we're using that in our UI, it just updates immediately. And so I can just have some UI that takes those to-dos and renders it. And but I don't like one thing here is I don't think the sync should be in React. So we can just move that out. So then we have global state for The to-dos, we can maybe put that in a different file. And now the component doesn't know anything about our sync system. Our developers don't have to know how the sync system works. We just work with the observables. So this sync system uses the observables to know exactly what changed in parts of the object, and it does all the hard sync logic for you. So we have a bunch of sync plugins. So the basic one is this fetch one, which basically just wraps around the fetch properties. But there's also a CRUD plugin. So that manages listing rows, determining which rows were created, updated, or deleted as you're working with your observables. So you just give it your CRUD functions, and it just does everything for you. So built on top of the CRUD plugin, we have more plugins like Keel, Firebase, and the Supabase plugin. So for the Supabase plugin, you just give it your client and the collection you care about. You can filter it, you can set up real time on it, and then it just syncs everything for you. I had planned to make a Pocket-based plugin for this talk after last month's talk, but I didn't have time. We'll do that soon. So basically, the messages observable is now syncing itself with Supabase. And so the components don't actually care about Supabase. So I could just change the observable to sync with Pocket-Base instead. And I don't have to change any of my UI code at all because it doesn't care. So that brings me to the 3 words that will make your apps better. Local first and sync. Plus is a symbol, it's not a word. So I hate these screens so much. Apps have always worked offline totally fine. Somehow over time, everything got worse. I don't understand it. If I have my team chat open on a plane, I can read the messages, but I can't reply to them. If I switch channels, it screws me over. If I close the app accidentally, it's all gone. I reopen the app, it's like, oh, you're offline. You were just showing it to me. Why is it not still there? It doesn't make sense. In my opinion, truly great apps work offline. They're fast because they have all the data locally. They don't need to sync anything. Since we have all the data cached, you can sync only the latest changes. So instead of syncing the entire database, you just sync what changed since an hour ago. So you get less server usage, less bandwidth costs. And if the server goes down, the app continues to work until it comes back. So I'll just show you a little demo here. So zoom in a bit. So this is my app legend. So I can say some stuff. Hi there. This is real small. Oh, I can't zoom in more than that. All right. So everything works fine. I'm online. Everything's cool. If you look at this, you can see this. What am I looking at? This. 6 seconds ago. So I'm making changes. Everything's good. I turn off Wi-Fi, and then this becomes offline. But I can still use the app. Hey there, I'm offline. Totally fine. If you go to here, it last synced 20 seconds ago. And so I can just turn Wi-Fi back on, and then shortly this will sync. So yeah, there it went. 2 seconds ago. So came online, reconnected, everything's fine, no problem. So back to local first is very hard. I spent years on making Legend do that. It was very difficult. Caching correctly is hard. Resolving conflicts from the cache and the remote data is hard. There's some special data types out there for merging conflicts. Google Docs use something called operational transforms. The cool new kid on the block is CRDTs. I'll be honest, I don't understand those at all. There's also some special databases that help with caching and merging. But as you can probably guess, Legend State does all that for you. So all that hard stuff is built into the sync engine, so you don't have to deal with it. So if we go back to this Supabase plugin for before, we can enable local first behavior by just adding 3 options. So we tell it we want it to persist locally and that we want to retry sync from the local changes. We can give it some parameters to retry, so I can have it do exponential backoff, retrying infinitely. So it'll basically just, eventually it'll wait 30 seconds before every retry, and then it'll sync only the diffs since the last sync. So now with those 3 lines, you get that sweet local first action. But you're probably thinking, well, that's really stupid because I didn't define room ID. Because what we really want here is a lookup table. So we say when we get a room by ID, it immediately loads the cache messages for that room, and then it syncs itself with Supabase and renders any new messages that came in. So all I have to do is at the bottom there, just get the DEVx room, the messages, and get them. That'll trigger this. First, it'll load it all from cache, then it'll trigger the sync. It'll re-render with whatever changed. And it's just so much easier when the local state and the remote state are the same thing. We just get, instead observables, we get a local first app for free. And this is very robust. This is everything I've learned about building Legend as a local first app since 2015, and in Bravely since 2022. And so that brings me to the 3 words that will make your apps better. Use Legend State. But for real though, the 3 things that make your apps better are good performance, because that makes users happy. Developer experience, because you'll build apps faster with fewer bugs. And user experience, because that's what everything's all about, to delight users. And users love apps that load quickly and don't make them wait. So thank you for listening to all of that. This was all about the features of version 3 alpha. It's used in production in Legend and Bravely, but I'm just giving some time to gather some issues and fix them, and there's just so many docs to write. But hopefully beta will be in a few weeks. So that the QR code goes to the GitHub repo, or talk to me on Twitter, or I'm Jesus on the Discord. And if you like the slides, those are made with slide.dev. I was very impressed with that. So that's it. So I thought I went too fast, and that was 5 minutes, but this says 20. That's crazy. So any questions?
Yes, any questions?
Hey,
Hi.
Yeah, man. Very cool, very awesome. Are there any dependencies I would have to install on top of Legend State?
Legend State has no dependencies itself, but if you're using Supabase, you need that, obviously.
Okay.
Yeah.
Would you know what the bundle size is?
The bundle size of Legend State is 4K.
Hmm.
If you include the React stuff, I think that adds 3 more.
Okay.
Sync is probably another 3 or 4. I haven't measured recently, something like that.
Awesome. Okay. Thank you.
Thanks for the talk. So where is the cache? Is it in local storage or session storage?
There's a bunch of plugins, so it depends on the platform. If it's on web, there's local storage or IndexedDB. And for React Native, we have async storage and MMKV. And then we could potentially make more, but those are the popular systems. Also for Legend, I made a custom one that saves to JSON files through Electron. So you can make your own too.
Question over here.
Do you have anything supporting or plans to support like end-to-end type safety?
That kind of depends on the server. So Supabase will generate types. So the Supabase, if you use an observable with Supabase, it will type it from that. Keel also is extremely strongly typed. If you're using something like Firebase, you just got to make your own types.
All right, question over here.
I enjoyed your presentation a lot. Thank
thank
you
you.
so much for
I couldn't see
for
you the whole
sharing it.
time.
I know. I just stood up and walked back there a couple times. But
Yeah.
my question is, what kind of license is this listed under?
MIT.
MIT. Okay. Thank you.
Any other questions? Yes.
Just a more general question.
Yeah.
How would you describe this as being different from just using global variables from a security perspective?
Just from a security perspective, what do you mean by global variables?
As in a variable, so you mentioned doing a structured clone, for
Yeah.
example, so you have multiple copies of something.
Yeah.
If everything is just referencing a single global variable at the top level,
Yeah.
which is scoped across everything, you then don't need to have copies of things.
Yeah.
So what is the advantage, or how would you what are the advantages that you describe for this versus using a global example?
I think it would be effectively the same, except you wouldn't have observability from an object. So you could just have a global observable instead of an object. And using local variables versus global is kind of up to you. It works either way.
One more question in the back.
With some of the other libraries that are using like state management and signals, there's some kind of gotchas sometimes with deeply nested objects. Is there any kind of concern, or how does Legend State go about making that work for what we need for our apps in deeply nested
There's no
context?
gotchas. Basically, if you're used to React, you're used to immutability. So some people coming into this get a little confused that like the object didn't actually change. So there's just some little learning to unlearn some of the React stuff. But some of the other state libraries will modify the underlying object, and so you get some kind of strange behavior from that. Legend State does not touch the underlying object at all. So it just, if you get the raw data out of it, it's exactly what you put into it.
Great, thank you.
All right. I think that isn't all time we have for questions for right now, but if there is any more questions, Jay will be here later to ask.
I'm aware that was very dense, so ask me questions later. Yeah.
For sure. I'll probably have a bunch of questions as well. But please thank Jay one more time for the talk. Next up, we will be having Brandon Jack do a presentation. Please welcome on stage. He's going to be doing a talk on video game development.
All right, testing. Is it working? Sounds like it is. Cool.
Yeah.
Okay. What's up, everybody? I'm giving a talk on how video games are the ultimate convergence of art and science. It's going to be much more casual, much less technical. So we can just start off with, who am I? I've been trying to figure that out for 28 years. But what I can tell you is my name's Brandon Jack, aka Shadowhand. I'm an independent game developer, aka unemployed. And I'm the creator of Demon Boy and some less cool things. So in order to understand where we got with video games today, we have to go back to the very beginning. And a lot of people think that the first video game ever was Pong. That's not true. Pong is a cheap ripoff, stolen by some people who couldn't think of their own game. Still happens today all the time, so it's fitting that it happened with the first one. But no, the actual first video game ever made was Tennis for Two. It was made by William Higginbottom in like a nuclear lab, and he actually worked on the Manhattan Project too. So yeah, all of this is just to say that video games were born from science, from a nuclear physicist in 1958. So it's very heavy on that. But where we are today with video games is they're just a big combination of music, storytelling, and digital art. And if you know what all three of these games are, then congratulations, we're now friends. I don't know if the audio is going to play for this, but show of hands, how many gamers do we have in here? All right, so about half, and then some other people who don't want to self-identify as gamers, which I don't blame you for. Hopefully this will, maybe I'll just lean in here, catch this, but this is. So yeah, I think that's how most gamers think that video games are made. It's just that beautiful 15-second clip. It's like, oh, don't need to watch that again. Go back in, I'm so bad at Okay, so here's how you actually make a video game. And you first think of an idea, accept that it's a terrible idea. That's just right off the bat, step one. Step two is think of a new idea. And I was gonna say better idea, but that doesn't always work out like that. And then step three is write a story for the game. That's always important for pretty much every video game. And that always comes immediately after the idea. It's definitely never added on in like the last 5% of the development process after you've been working on a game for months. And then step four is you make some cool art for the game. Or if you don't know how to do that and you're just lazy and untalented, you get AI to do it for you. I spent hundreds of hours learning how to make it myself, and I kind of regret that decision, so no judgment for the people that do that. And then step five is add in some music. You can also learn how to do that or hire someone or just steal it because, I mean, your game isn't going to be big enough to actually warrant a copyright claim. And then, and then once you've done all that, you throw it all together in a game engine. And let's be real, it's going to be Unity because Unreal is way too hard. And if you do that, it'll look a little bit something like this. So yeah, you can, there's models in there, there's a little world and particle effects, and some of the animations even work, but I don't know, this doesn't look super exciting. It's kind of like there's something missing. And that thing would be code, obviously. And so this is what that exact same game looks like with all of the scripts checked marked on. So the code functioning with it. And this is much more exciting, much more like something that actually resembles a game. Can run around, jump, throw some fireballs, fight some enemies, and even the flames are turned on, and it just looks like a real video game. So that's enough of that. We don't really need to continue that. And here, gotta go back in. And so we're gonna take a look at the player script for my game Demon Boy that I've been working on for a few months. We can come back to this video. It's actually much less complicated than the video we just saw. So here we have the player script, and the great thing about being a solo developer is you don't have to worry about anybody else seeing your code unless you decide to do a talk for a bunch of people in a room in San Diego about game development. So please forgive me, but here's where you would, set a bunch of variables. This onCollisionEnter function handles, collisions with the player just bumping into different things like some of the enemies and the projectiles and triggers here. This obelisk is like 400 lines long. Here we have, some jumping functionality, the movement functionality. But yeah, you can see that it's like talking to an animator. That's code telling it what to do, how to look, and different things aside from just handling the actual game functionality of it. So here we could go back to, guess we can watch this video. This was a very early clip from like a couple months ago when this was all it was. But yeah, so the code is taking the input from the player and telling the actual on-screen character what to do. And then we have another script, which is the Harpy. This is the most recent thing that I've made. It's the wrong thing again. Oh yeah, for sure, absolutely. And the thing about the harpy that I really like is she takes, where are they? She takes these two random values that set her attack spot to somewhere around the player, and then she attacks and comes back to that attack spot, start this coroutine. Coroutines are super fun and interesting because they start some code. Let's look at this. Where is this? So what a coroutine does is you enter the function, you run some code, and then you actually return to it after a certain amount of time. And it's funny because this is probably the only one that doesn't use the wait for seconds. But here's another one. So it'll wait for 3 seconds, come back, and then actually destroy the harpy. We have a video of her doing her thing. So she starts out, she coming into range here. She's gonna throw one projectile. I'd give her a second to do that just to show off the state. And then if her health goes down to 2, which it now is, then she'll start doing her dive attack right here, and you'll see the random range come into play. But yeah, so that's just another one of the enemies that we got. And then the final boss enemy, Demon Dad, because the story element of Demon Boy is you gain your powers and try to go fight your dad. And he's not based on my dad. My dad's great. I love my dad. He's not here, but he's awesome. So no correlation, because Demon Dad's kind of a dick. But here he is in Unity. This is the actual editor. So we'll dive into his code a little bit here. Turn gizmos on. And so the blue sphere is his melee range. The red sphere is his like fireball range, and then you'll see what the green sphere does. And then the yellow is just chase and sight range, I guess. It should be way bigger, but I scaled it down. But let's figure out what that green one is in a second. Another obelisk here, probably well over 300 lines. But yeah, so this is like the state handler machine. It's checking if the player is in sight, if he has a height advantage, because if you get too far above him, he'll teleport above you and then come dive down. And all of these things are just right here testing to see how far away the player is from Demon Dad, and that determines what his attack will be. And yeah, then a bunch of other stuff that took a really long time. And here, let's go back to the presentation. You can watch Demon Dad in action. Actually, we could skip forward. All right, here we go. Had to go get those power-ups because it's pretty hard to beat him without them. So yeah, that's the Comet Cloud ability that I was talking about earlier. That's the green sphere. And just throw some fireballs at him. He's really easy in this video because I scaled down his health a lot to get this clip. But he's much more difficult to beat. Yeah, you can actually just dive on him and just brawl it out. Super exciting stuff. And then he dies. And the game ends. Except not there, because I didn't put that in yet. Okay, so the art side of things is, what we just saw was a lot of the code that I wrote to get these things moving. But I spent hundreds of hours learning Blender, making these 3D models and learning how to animate them to get them to move. And so really, whether you think he's pretty or ugly or interesting or not, Demon Boy is kind of the culmination of all of my creative and technical skills, and that's what video games as a whole are. And that's my talk. So. You can connect with me on my site, brandonjack.games. It's got my LinkedIn. You can actually play Demon Boy there and some other stuff too. But that's it.
All right. Do we have any questions? It looks like we have a few, so we'll start up front.
With the work that you did in Blender with assets that you created, is it easy if you were to hire another designer or artist later to just swap in those new assets, or is it a whole lot of rework?
I think getting the animations to work right specifically would take a lot of time. So like I think what you're asking is like if I had just a game without all the art assets and it was just like some pills jumping around.
Yeah.
And then you like added this stuff in later. You could do that, and there is a saying that says that you in that state your game should be fun to play, and if it's not, then like the art really isn't gonna matter. Which is a fair point, but it would still take a long time to do that, I think. Like, some people do it, but they get the assets in the beginning, and then they write the code for them later, because trying to get them to animate and stuff, like, if you try to do that all at the end, you're like, oh, this clearly doesn't work. Like,
got it. I had just one more. With the framework that you're using, I think you said Unity, right?
yeah, it's Unity.
Are there any sub-frameworks that you came across? Like, for example, in Python, JavaScript, there's hundreds of frameworks. Noticed you had a fair amount of code. I was just wondering, are there any libraries that you came across where some developer like yourself has built a library for other people using Unity that abstracts it away? Or do
There's
you
a
have to roll
lot of
everything?
stuff like that. So Unity's really cool. It has like the add-on store. You can actually, in the editor, you go and you search for stuff like that other people have made. And there's art assets, but there's also like real add-ons that software developers have made. And a lot of those are super useful. I use a few of them in Demon Boy. So yeah.
Cool. Thank you.
Yeah.
Just to follow up on that answer, yes, there are libraries that will let you get full 3D models. Turbo Squid is one. There's a bunch of others in addition to the Unity Unreal stores. Humble Bundle, if anyone hasn't heard of that, they have tons of stuff on there. And if you make a game, you can almost do the import first-person shooter. Those are called asset flip games, and they tend to be terrible, but they look really good for the first 30 seconds if you need something like that. If you want to make something simpler and you don't need 3D, actually Blender does 2D with the grease pen tools as of version 3.5 or 4, and Godot is also super easy to work with. I did an animation project for someone on that so that they could use an Xbox controller to essentially control a live avatar with a few pre-programmed animations. I'm not good at doing any of those things. You don't want to pay me to do any of that.
What would you say are the best 3 to 5 video games of all time?
Oh, jeez. So for indies, it's got to be Outer Wilds, Risk of Rain 2, Hollow Knight, and then, oh man, 2 more? I don't know. That's hard. I like Halo Reach, and I really like Metroid Prime 3 too. It's like Wii game, but I like that one a lot. So I think that's probably my answer. Yeah.
I have a question. What is on Demon Dad's chest that's glowing?
Those are his nipples.
Okay. Thank you.
Everyone's naked because it's hell and it's really hot. He doesn't. Don't look closer.
So I heard you said you were working on this for a few months. What were you doing before this with coding? Were you doing games before this still, or something else?
Yeah, I was doing games. I had a job at General Atomics So it was, I was just working on stuff that I'm not really allowed to talk about it because they're a defense company. But yeah, C sharp. It was C sharp though. So, and C sharp is what I use for Unity games, at least. Yeah. But yeah, I'm really trying to break into games right now. I'll probably just go back to regular tech if I can't find something because the market's not good. It's even worse for games than just normal software right now. Yeah.
You can make them dance.
Yeah.
It's worth something.
Yeah, for sure.
How many hours did that take?
Just this? I mean, everything that you're looking at probably took like 50 to 60 hours, but just the dance was not that long. But like those two models took 20 hours to make total for those two. And then the animation's probably another 10. Or no, that animation's probably like 5. Yeah.
Did you already add music and story to that game, or is that something you'll do in the future?
I have it. I just haven't put it in yet.
Okay.
But yeah. So yeah, I have those things ready to go. The game should be done soon, but like I've just been working on the really hard things, doing the actual coding, the mechanics down, and then I'm adding all that stuff in later.
Looks very interesting.
Thank you. Yeah. I mean, oh, by the way, I will be having playtesting going on if anyone's interested after the next speaker. Yeah. So come over. I'd love to get some feedback on it.
Cool. I'll do the honors of having the final question. I think we have time for one more. What would you say is one of the main driving benefits of using Unity over Unreal Engine? Because you did mention Unreal Engine is way more complicated. So what particularly about Unity really helps you as a developer or a game designer?
Unity has really good documentation. It is easier to also get multiplayer functionality working in Unity. And there's just a ton of tutorials. I don't look at tutorials anymore, but like, if there was something that I didn't know how to do and I couldn't find documentation on it, I'd look it up. I mean, I think Unity is really good for people starting games to make games because there's just so many tutorials. Like there is like a first-person shooter in 15 minutes video that, has you set everything up. But yeah, I mean, the graphic rendering isn't as good, but the documentation is there. It's amazing. A lot of times I just forget like some function that I know or some aspect of the library that's going to help me, and I know what I need to do, and I just Google it. Boom, there it is. Unreal, that's like impossible. It's like it's really hard to learn how to use Unreal just because there's no tutorials and the documentation is bad. So I think that's probably the main thing for Unity. And yeah, and also multiplayer, that's a big one too. It's easier to make a multiplayer game in Unity than Unreal, in my opinion. Yeah.
All right, everybody give a hand for Jack, Brennan Jack. And then for our final talk, we have Colin here. He's going to give a talk on Next.js and how that is a way better developer experience than React.js. You're mic'd, right? Cool. Make sure.
Now it is.
Okay, perfect.
Oh, it's that side. Yeah.
All right, round of applause for Colin.
Can y'all hear me? Yeah. Nice. I don't know why I still got a blue screen. Maybe we need a different connection.
We can try that.
We can check that out.